Okay, let's talk about the graph of cosecant. So it's a lot like secant, the exact same idea. Remember, be on the marker. Recall cosecant of x is just 1 over sine of x. And again, we should be experts at graphing sine of x. So here's pi over 2, pi, 3 pi over 2, and 2 pi. And we could go backwards a cycle if we want. Here's negative 2 pi, negative pi, negative 3 pi over 2, negative pi over 2. So any place sine equals 0, cosecant will be undefined. Just it's the same idea as what we did in the last video. Because you can't divide by 0. If the bottom's 0, we got big problems. So if sine equals 0, cosecant of x is undefined. So where does that happen? What are these spots here? Those are all at the pi's. I mean, we could see them, right? At 0 pi, 1 pi, 2 pi. This next one would be 3 pi. This next intercept here would be at x equals 4 pi. So that's at x equals n pi, where n is any integer. Or to make it kind of symmetric, remember with cosine, the bad guys were at the odd pi over 2's. So I could say this, I could say x equals k pi over 2, where k is even. Because if k is even, this 2 is going to cancel out, and we'll just have a whole number or an integer number of pi's. So that kind of makes it symmetric with secant, but either way is fine. The bad guys, the asymptotes for cosecant, will be at the pi's for regular old cosecant. Okay, so if we wanted to just sketch out a quick graph of cosecant, we graph out sine first, kind of as an auxiliary graph. 2 pi, pi over 2, 3 pi over 2. Every place we cross the axis, we get a vertical asymptote. So all of these intercepts, we get asymptotes. And then all of these hills get turned upside down. Those touch right there. And all these valleys get flipped down. Everything gets flipped inside out. There was another asymptote here. I kind of missed. Let me hit that a little better. And we just keep going. This goes on forever. Like, obviously, I can't draw all of them. So the blue graph here, along with the axes, of course, is the graph of cosecant. It's just sine turned inside out. So my domain all real numbers, except we're not allowed to use n pi, where n is an integer. All of those will give us 0 in the denominator. And our range, exactly the same range as secant. I'm using all of these y values here and here. That's negative infinity up to -1 with a bracket, because I actually use it right here. Remember, this is 1 and -1. And then 1 to infinity. That's a parenthesis there on the end. So sine is using all this stuff in there. That's negative 1 to 1. Cosecant uses all the stuff outside of there, including the negative 1 and 1. Okay, so let's do an example. Let's say, I don't know, let's sketch y equals 2 cosecant 4x minus pi. That'd be a good one. Okay, so first thing we want to do, step 1, forget about cosecant for a minute. Let's graph y equals the associated sine function. 2 sine of 4x minus pi. We graph his buddy first, and then we just flip it inside out. So we find our amplitude, which is absolute value of A. A here is 2. Absolute value of 2 is 2. We find our period, 2 pi over B. B is the number multiplying x, so 2 pi over 4. Maybe I want to reduce that to pi over 2. Maybe I want to leave it pi over 4. Maybe I'm going to want pi over 8. I don't know. Or that would be 4 pi over 8. Okay, we find our phase shift. Our phase shift is always opposite of C over B. Opposite of negative pi would be positive pi over B. 4. Our vertical shift. I'm never going to give you a vertical shift with a secant or a cosecant. Like, these are bad enough. I'll just go ahead and give you a hint here. The vertical shift on secant and cosecant will always be 0. K equals 0. No vertical shift. We do start and end. So we take the inside, set it equal to 0, and 2 pi. For sine, cosine, secant, and cosecant, start and end is always 0 and 2 pi. Tangent and cotangent are different. We'll get to those in later videos. Those are different. They have their own rules. Sine, cosine, secant, and cosecant, it's always 0 and 2 pi. Okay, so here we get 4x equals pi, which is x is pi over 4. Hey, that's the same thing we got for the phase shift. Yay! Here we'll get 4x is 3 pi, adding that pi over. So x is 3 pi over 4. We should always check. End minus start should be the period. 3/4 minus 1/4 would be 2/4 pi. 2 over 4 would be, oh, look, well, we even had it like that. 2 pi over 4. Good. Okay, our scale. The period over 4. Let's use the reduced version of the period. Let's make our fractions a little easier. So pi over 2 over 4. We got to do a little keep, change, flip. That's pi over 2 times 1/4, because that's 4 over 1. That's pi over 8. That's my scale. Let's make everybody look like that. Our life is going to be a lot easier if everybody has the same denominator. So I'm going to make these guys 8. we're going to make the period 8s. He will be 4 pi over 8. Just multiply top and bottom here by 2. Everybody's 8s now. That makes us happier. Okay, who are we graphing? I don't even remember. We're graphing a sine. So we draw a nice pretty sine wave. Oh, and I typically, when I'm doing secant and cosecant, I try to make these dotted. Let me make him a little taller. But this is not necessary. It's not required that you make this guy dashed. I think it does make the final picture look a little prettier though. Okay, no vertical shifts. Our x-axis comes right through the middle. We're graphing sine at the moment. Here's one period of sine right there. That's our main period. So here's a start. Here's an end. I know what numbers to put there. I just found them. 2 and 6 pi over 8. And I'm counting by pi over 8. And remember, we're going to count every crest, every intercept, and every trough. And I'm counting by 1 pi over 8, so I'm at 2. This will be 3, 4, 5, and 6. Good. I landed on something I already had written down. That's a good check. Let's count backwards. I'm at 2. If I go backwards 1, I'll be at 1 pi over 8. Minus 1 more will be negative. Oh, no, it won't. Minus pi over 8 will be 0. That's the y-axis. And let's do 2 more. Here's negative pi over 8 and negative 2 pi over 8. We should always try to have a full period, both positive and negative. So I wish I had a little more back here, but that's okay. Okay, we put in our amplitude. That was 2. So our highs and lows are 2 and negative 2. See, amplitude was up here. Okay, that's sine. We've graphed this guy. We're done with him. Now let's flip him inside out to get his buddy, cosecant. So I'll do this in a different color. Let's change this to blue again. At all of the crossings, we get a vertical asymptote. Now, a lot of times I'll see people do this. They'll put a big dot there and then draw a line through it. No, there's no dot. They're just a vertical asymptote. At all of where sine crossed, we get a vertical asymptote. Then we turn it inside out. Every one of these humps here gets flipped up. Imagine this guy here just getting rotated up. Like I could put in all the humps first if I want. They're all going to go up instead. Instead of facing down, they face up. Oh, I went too far there. Remember, you never cross an asymptote. And these are inside these lines here. These are like force fields. They're walls that we can't touch. All of these valleys here, these guys here, these troughs, they get flipped down. And that's it. There is the graph of whatever it was we were graphing. Cosecant of 4x minus pi. We've got our amplitude on. That's the place people forget. Don't forget your amplitude. And that's a good place to stop.